In recent years, stainless steel dentist instruments for tooth canal treatments have been successfully replaced by Nitinol endodontic rotary files. Due to nickel-titanium memory effect, NISHA instruments do not deform. They can break without warning when submitted to excess stress and material fatigue. In order to avoid the unpleasant consequences of instrument fracture, it is advised to use the file in the canal with both a constant rotation of approximately 280 rotations per minute and a controlled force torque according to the size and design of the instrument. One of the European manufacturers named Aimtwo the Nitinol endodontic rotary files. Aimtwo cuts as it advances in an apical direction. However, if it does not advance easily and the instrument is subjected to stress by prolonged contact with the canal wall, it is advised to withdraw it about 1 to 2 and use in a passive filing motion. This allows space to be created so that progression towards the apex can be continued. Before doing this, the instrument should be visually checked for signs of wear and should be cleaned of debris, if necessary. This process is repeated a second time and it is sometimes necessary for particularly difficult root canal. For optimum safety, it has been advised to use an Aimtwo instrument only once. In fact, the number of times the instrument is used depends on the stress exerted on it. Nitinol's the almost equiatomic binary intermetallic compound of nickel and titanium applications have been steadily growing. The main reason for this is the remarkable combination of mechanical and biocompatible properties. The unusual mechanical properties of Nitinol are due to its ability to undergo reversible change between two crystal structures. The good biocompatibility originates from its chemical composition. The oxide on Nitinol, with the spontaneous creation of very titanium-rich oxide, is of paramount importance for its biocompatibility in orthopedic, dental and biliary applications, as well as hemocompatibility in cardiovascular, peripheral stents, and another implantable devices. Electropolishing is one method commonly used to modify the metal and alloy surface to make it more bio and hemocompatible. Near-equiatomic NISHA alloy has become ubiquitous among biomedical materials used as prosthesis and endodontic instruments due to its mechanical shape memory and supraelasticity, peak erosion resistance properties, and, most importantly, biocompatibility. The combination of Nitinol's rare mechanical supraelasticity, superplasticity and chemical biocompatibility, hemocompatibility properties make it widely used, both as an implantable and endodontic material. It is well known that surface roughness and surface morphology greatly affect the mechanical properties of metallic endodontic files. In case of endodontic instruments, the mechanical resistance to fracture is one of the most important features, with the electropolishing process affecting fracture resistance of the rotary NISHA endodontic instruments. However, although the standard electropolishing process improves different properties and enriches the passive NISHA layer in titanium, magnetoelektropolishing further enhances the concentration of titanium in the passive layer and further affects the mechanical properties. These results obtained after MEP include a decrease in nickel ions leaching and eliminating the elemental nickel from Nitinol surface. Aimtwo file has two cutting edges which form long spirals formed on conical shaft to ensure better control of instrument progression during intrusion. The backs of the cutting edges are sharp to optimize cutting efficiency and facilitate advancement of the instrument in the tooth canal. The tool has maximum space for removal of dentin and minimum radial contact, though the core width is designed for maximum flexibility without compromising the instrument's strength. It undergoes a quite prompt damage during operation. The distance between the blades increases from the tip of the file towards the shaft. The pitch is progressive and the space for dentin removal is deeper at the back of the blade, helping to reduce blockage and the accumulation of dentin chips. The progressive pitch allows the instrument to proceed towards the apical area safety whilst working more efficiently in the coronal third. The main advantages of niche endodontic files are: 1. A shape, memory effect, 2. High flexibility, 3. Respective canal morphology, 4. High fracture resistance, 5. Optimal resistance to corrosion. Experimental method. 2 sets of aimed endodontic files were subjected to the study. The first one as received AR and the second one after magnetoelektropolishing. A typical cross-section of the nitinal endodontic instrument. Scanning electron microscopy was used to investigate the fracture and nitinal structure. With this method also the nitinal EDX spectrum was received. The surface of endodontic files was studied by interferometric method with Taylor-Hobson precision Talasurf CCI 6000. Coherent correlation interferometry. It is a powerful instrument allowing for getting multiple surface characteristics. Results of the study. Observations of broken endodontic files have been performed by means of SEM. The side view of the used endodontic file in its close-up from above. Close-up of broken endodontic file with the cutting rim visible on the left. SEM analysis results of the nitinal endodontic file presenting EDX spectrum. The prevailing peak of titanium is visible, with nickel peak clearly seen as the second one and a minor traces of some other elements. The view on fracture of their endodontic file. Nitinal structure is visible, proving of specific superelastic properties of that material. A conventional practice is to rinse their endodontic instrument in lysoformin, to disinfect and keep it for about 15 minutes to get it biologically sterile after use. During operation the instrument is periodically rinsed in 10 ml NaCl and 5.25% sodium hypochlorite, in view of removal dentin from the instrument. Such operations provide very often with formation of accretion on the instrument's surface, and thus inevitably affecting the mechanical properties of this instrument. Under a normal operation their endodontic instrument undergoes periodical submerging, rinsing. The rinsing operations of their endodontic files in the higher mentioned solutions for some period of time results in formation of the accretion, and formation a layer with observed traces of disruption on it. Such a state of an endodontic file may affect the occurrence of some changes generally in its mechanical properties. A very simple mechanical experiment, relying on cutting and bending, was carried out to study the changes in nitinal endodontic files, revealing quite brittle and fragile structure. The instruments after operation behaved very different than before. We have magnetoelektropolished those used endodontic files, and the experiment was carried out both on the plateau level of magnetoelektropolishing polarization curve, and much above it. Their interferometric surface analysis of magnetoelektropolishing endodontic instruments showed typical patterns with very smooth surface finishing. In both cases a recovery of superplastic properties was gained, relying on impossibility to easily cut the instrument, which was possible after several bends. It is a different behavior of their endodontic instruments in relation to those after operation and before magnetoelektropolishing. Conclusion. Now, studies aimed at the wear control after normal use and investigation of magnetoelektropolished nitinal endodontic files to compare them with the as received ones available at present. The investigation results obtained indicate on a considerable improvement of MEP surface in comparison with as received surface. Such a surface reveals several positive features. and decreased roughness, which surely affect mechanical properties, specifically fatigue resistance. The detailed advantages may be expected after performance of the next stage of the studies, directed on specific mechanical properties of their endodontic files at work.